to lecture number 39, and we have been considering mutually coupled coils. There may be two or more coupled coils having their respective self inductances and mutual inductances between them, and it is essential that you must show the polarities instantaneous. You must convey to that diagram the instantaneous polarities of the induced voltages in the respective coils with the help of some dot convention. Okay. And I told you that if suppose, and henceforth I will draw the coils horizontally, it does not matter. In my mind I know that these two coils are wound on some magnetic circuit like that, and if you show this is dot, this is dot, it is sufficient so far as to find out or write down the KVL where mutually coupled coils will be present. To this much information I must expect, so that I will be able to write down the equations correctly. Now, in general what will happen, both L1 and L2 will carry current. Okay. They will be connected to respective supply voltage, and recall that if you have a single inductance, I told you that this is I1, no mutual coupling with other coils. This can be thought of a voltage source. If I1 is increasing and dI1 dt is positive, this will be the polarity of the induced voltage L1 di dt, dI1 dt, like that. Now, suppose let us say, let us take a concrete example. Suppose these two coils I have connected, and the terminals of these two coils is, this is AB and this is say CD, and these two coils, suppose they are connected in series like this, so that it will strengthen your concept of dot convention. And here you have connected some AC sources, alternating sources like this, plus minus, and that is causing some current to flow in this circuit, say IT, and these two coils are connected in series. Then I want to find out the current response of this circuit. So, for that what I have to do? I have to write down the KVL. There is no escape from that rule. If you want to find out the current, if you know the voltage, you have to write down the KVL, and that is why the polarity of the voltage induced must be known. Now, let us see, this circuit is fine. These are having self inductance L1, L2 and M. So, between points A and B, let us see what are the things A and B. Current is entering here I1, there will be a voltage source present whose polarity will be like this, because I1 is I is like that. There is they are series connected. So, I1 to I2 to are same, as you can easily see, and here I can write L di dt, is not, that is what I can write. Then the story is not story does not end here, because now these two coils has got a mutual coupling with mutual inductance same. Therefore, because of current in this coil, there will be induced voltage in the coil AB, which will be M di dt. For a single inductance, here everything is over, but for mutually coupled coils it is not. Because of self inductance, there will be a voltage source. and because of mutual inductance, because second coil is carrying current I, same current. So, M di dt. But I must write down what is the polarity of this induced voltage, that instantaneous polarity. Okay. Second coil, through the dot current is entering, therefore, the induced voltage in this side must be this side plus, is not? This is what. Suppose di dt is positive and it is entering here. So, second coil, through the dot if current enters, the other dot becomes plus terminal. So, to the left hand side it will become plus towards A. That is what between A and B we have now two, as if two sources of EMF. Similarly, then you come to the point C, B and C are same point, no doubt. Here is I flowing, come to the second coil C and D. Across CD, I will say that okay, look here, it has got a self inductance. So, it will have induced voltage L 2 d I dt, that is the rule of self inductance, and current is shown entering here. Therefore, this must be plus, this must be minus. But then the first coil is carrying a time varying current. So, it will cause an induced voltage here, and that will be M di dt, M di dt, that must be. The question is, what should be the polarity of this voltage? So, polarity of the voltage will be through the dot, current is entering in the first coil, it is causing an induced voltage in the second coil, whose dot is known dot. So, this side, C side will become plus and D will become minus, and then you are done. And here is your supply voltage. Because mind you, to find out currents in a circuit, you have to write down the KVL. Then if it is algebraic equation, algebraic, if it is differential equation, differential, and we now know how to handle them. So, in this circuit now, this is suppose V t, then I will say the KVL equation will be from this point you start here to here V t is equal to then minus L 1 d I dt, all those terms you take it on the right hand side, it will be L 1 d I 1 d I dt, no d I 1 plus A m d I dt plus L 2 d I dt. These two terms is the voltage across A B, and these two terms M d I dt is the voltage across C D. This is across A B, this term is across C D. This is the story, and this of course can be written as L 1 plus L 2 plus 2 m d I dt, is not. So, applied voltage is this one L 1 plus L 2 plus 2 m, and this is d I dt. This is the thing. I can say this much, see, I have applied some voltage and it is some constant into d I dt. So, I can say L equivalent of this circuit is this. This is the thing I will tell. What the point? So, L equivalent of the circuit can be calculated. What will be the energy stored in the system? Half this L equivalent into I square. So, and similarly, I will not do that, but I will tell you what is the difference between these. Suppose these are the two coils, but you practice it, so that it will give you more confidence in handling mutually coupled coils. Suppose I showed that this is dot, this is dot. This series connection I could also do like this, the other way around. I will quickly write down, so that, and this is the applied voltage V t across the combination. Okay. So, I will assume the current I, once again same current flows, and let me call this as A, this as B, and this as C, which I called it earlier, and this as T, is not. So, I have connected like that. Now, first A B, between A and B, and mind you, these two coils has got a mutual inductance, which is shown like that, N. So, across A B there will be two sources of EMFs. Now, listen carefully. Here, so far as self induced EMF is concerned, L 1 d I dt, it will try to oppose the change in this I. So, this is plus, this is minus, nothing. But there will be another voltage source, because of the fact that the second coil C D also carries current. And what will be the magnitude of this voltage? M d I dt, d I dt. This will be the thing, is not? But this time you should be careful. In this case, current is entering through this terminal, not through dot. Therefore, this will become plus and this will become minus. So, through whichever terminal current is entering, this current, which is causing an induced voltage here, that side it should be plus, plus, minus. So, I think you must understand this point. Suppose there are two mutually coupled coils which are shown dot dot, and this is mutual inductance. Okay? Suppose this is A, this is B, this is C, in general I am telling D. Now, what you do, these two dots are given, it is also equally correct these two dot has been given, other two terminals will also have like polarities. When this is plus, this is plus, at that time this was minus, this was minus, but some instant this will become minus, this will become minus, this will become plus, this will become plus. In other words, what I am telling, if you say you erase these two dots, these two things are absolutely okay. Same pair of coils with these dot markings is same as same pair of coils with these dot markings, no problem. That is, you can use some other symbol. This is dot, some which when you are very expert, you do not need to do that. Square you write. Okay. They also represent like terminals. Therefore, if this is square, this is also square. Need not be done. I mean, I am telling you the logic behind it. So, through so this can be, this square also can be treated as dot, forget about this. So, through the dot current is entering and this side will become plus. That is how I have drawn it. I think you have got the point. So, so once this is done, I will go to the second coil, that is C and D and terminal D. and between these two also there will be two sources, is not. One source is the current due to self inductance. Current due to self inductance. For this coil, current is entering, I am so sorry, please forgive me. This is the connection, I should draw correctly, exactly the same way. That is, your this thing now goes to D and then your C here, then your supply, where B T you have connected, plus minus B T. Got the point? So, here current is flowing like this. So, first the self induced voltage, current is entering through this one. So, this is plus, this is minus, and this is L2 d I dt, you know. And then the first coil is carrying current, then it will have another induced voltage because of mutual terms, which will be M d I dt, and through the dot current is entering. Therefore, its dot terminal here will have plus. So, this will have plus, this will have minus. Got the point? Then write down the KVL V t from this to this plus, minus to plus, then from this to this minus L 1 d I dt, then minus to plus, plus M d I dt, then from here plus to minus. So, minus L 2 d I dt, and then minus 2 plus, plus M d I dt, and this must be 0, that is what KVL laws tells me. Therefore, this can be written as V t is equal to L 1 plus L 2, take everything on the right hand side, minus 2 m into d I dt, and we say that L equivalent is equal to L 1 plus L 2 minus 2 m. Therefore, if you connect two coils in series, the equivalent inductance between those two coils, which are having mutual coupling between them, will depend upon the connections. For example, two resistances I connect in series, R 1, R 2. Okay. Whether you connect it like this, equivalent resistance is R 1 plus R 2, or whether you connect like that, it does not matter. Equivalent resistance is once again R 1 R 2, but with inductances or coils which has got mutual coupling, you should be careful. The series connected, no doubt they are, but equivalent inductance between the terminals will depend upon whether they are additively connected, like L 1 plus L 2 plus 2 m, or in a subtraction mode they are connected. You should be careful. The next problem, which I will not solve completely, but I will leave it as an exercise to you, is suppose okay, these are the coils, two coils. Just it will hopefully, as many exercises you do, you will understand it better. That is what I think. Suppose these are the two coils, okay, and these two coils has got self inductance L 1, L 2, and mutual inductance between them is like this, like that. I have connected like this. Okay. Now, what I will do, I connected these two coils in series earlier. Now, these two coils now connected in parallel, you connect them in parallel, and once again tell that this terminal is A, this terminal is B, and this coil terminal is C, this coil terminal is D. Of course, A and C are same point, B and D are same points. I want to find out what is L equivalent to this parallel combination. I am assuming the coils are having no resistances, okay, inductance. Okay, what I will do is this parallel combination, across this parallel combination, I will connect a AC voltage source V t. With this polarity, polarity is important in solving circuit. Whenever you have to write down the KVL equations, the polarity of each element must be known, voltage polarity. Then only you can correctly add them up, otherwise not. So, anyway, here first thing is first. Suppose somebody has drawn a circuit like this, no dot, nothing, L 1, L 2 and telling mutual inductance between them. Then I have every right to ask whoever has given me the problem. Unless you give me the dots, I cannot do it, because I do not know the sense of the winding. Otherwise, I could find out if you give in totality the magnetic structure and the sense of the winding, then I could be able to find out. But here I cannot proceed unless you tell me, because dot convention is essential to know the correct polarity of the induced voltage due to self inductance as well as due to mutual inductance. So, that is why dots are given, these two are the dots, that is okay. Achha, now across AB what is happening? Let us see. Achha, first of all, I will say that let the current drawn from the supply is IT, let the current, and let this current be I 1. Then I will apply KCL at this point and say that current flowing in this coil is I minus I 1, is not. So, I minus I 1 is flowing here, and the direction I have mentioned, and this is I 1. If that be the case, let us try to see the voltage drop across AB in the first coil. Okay, L 1 current is entering I 1. So, with L 1 there is no problem, plus minus it has to be, this is I 1 and this I will write L d I 1 dt. But I know second coil is carrying current and there is a mutual coupling between these two. So, there will be another source of EMF here. What will be the value of that? M d dt of current in the second coil, which is I minus I 1. That is what it came out to be. Now, the big question is, I must write down the polarity, otherwise how can I do anything? What will be the polarity of the induced voltage? Through the dot I minus I 1 is entering, and because of this current I am calculating the induced voltage here M d I 1 dt. So, through the dot, if it enters, this dot will become plus. So, this will become plus, this will become minus. This is the story of AB, coil AB. What about coil C? This coil has got two terminals C and D. There will be induced voltage in this coil, which is having a self inductance. Current is shown to be flowing like this. This is I minus I 1. Therefore, it should have L d I minus I 1 dt. This is straightforward. And then there will be another EMF here, the value of which will be because of current in the first coil, which is I 1, and this has to be m d I 1 dt. Now, the next thing is this is plus, this is minus, or this is plus, this is minus. Who tells me that? This dot convention. Through the dot, current is entering in coil A B, and that current is causing a induced voltage here, where the dot is known. So, the upper should be plus, lower should be minus. And then the circuit is, these two are parallel connected. Now, I draw this circuit, this is parallel connected, and here is a voltage source V t, this is the voltage source, and this current I called I t. So, I t I 1, then this is I minus I 1, current in the second coil is I minus I 1. So, this current was I minus I 1. Suppose I have been asked to calculate L equivalent of this circuit. Now, L equivalent means what? My strategy will be to get a differential equation which will have a constant term here into d I dt. If I can write it like that, I will say this constant is the L equivalent. That is the idea, that is how I will try to go. So, now you see these two are parallel circuit. So, first thing is V t applied voltage here will be equal to, in this branch it is L 1 d I 1 dt plus m d dt of I minus I 1. Also V t in this loop, it will be equal to L 2 d dt of I minus I 1, is not, plus to minus, then once again plus to minus, plus m d I 1 dt. This will be the thing. So, what is to be done? From these two equations, you have to eliminate I 1, try to eliminate I 1, try to eliminate I 1. Okay. Now, equating the right hand side, equating the right hand side, because these two are same as V t, I will say L 1 d I 1 dt plus m d dt of I minus I 1 is same as L 2 d dt of I minus I 1 plus m d I 1 dt, like this, I will get it. So, what you do? You collect the terms which are having I 1 terms. So, it will be L 1, this term I 1, and this term is I 1 minus L 1 d I 1 dt minus m d I 1 dt, and if you bring this term this side, it will be plus L 2 d I 1 dt. Another term is there, and minus, sorry, yeah. Are you getting? Okay, I will write it first. It is, let us not hurry. So, collect the terms d I 1 dt on the left hand side. So, it will be L 1 d I 1 dt, let me write in longhand, minus m d I 1 dt, that is the second term. Then this one will be plus L 2 d I 1 dt this term I have taken, and this term is also I 1. So, minus m d I 1 dt. This is the thing I will get on the left hand side. Right hand side, bring all the terms having d I dt. So, d I dt, there is L 2 d I dt is already present on the right hand side, that is this term, that is this term, and another d I dt will come only this one, that is this term. So, minus minus m d I dt. This is the thing. So, I will write L 1 plus L 2 minus 2 m into d I 1 dt is equal to L 2 minus m d I dt. Fortunately, here in this particular example, all I and I 1 terms are coming in terms of d I 1 dt or d I dt. Therefore, my objective was to eliminate I 1, means I now know, therefore, d I 1 dt is nothing but L 2 minus m divided by L 1 plus L 2 minus 2 m into d I dt. Is it? This is d I 1 dt. So, put it back in any of these equations, 2 m. Thank you. So, this one I will now suppose take this equation, and I will this I will not complete, I leave it to you, but only thing I will say, okay, then V t is equal to L 1 into d I 1 dt, and d I 1 dt is this one, L 2 minus m divided by L 1 plus L 2 minus 2 m. This is d I dt, is not? This is the first term. Then minus m d dt, d I dt minus m d I dt. This you open the bracket. Oh, I could do it in one line anyway, and then minus, this is plus, and then minus m d I 1 dt. And once again for d I 1 dt, put these numbers. So, everything is now some constant into d I dt. From that you please try to find out tail equivalent. Got the idea? So, first thing first, do not get confused about the dot convention, that is one thing. Unless you do not know the dot convention, you will not be able to write down the you will not be able to show the correct polarity of the voltages, which is essential in writing KVL equation. And why should I write KVL equation? Because I want to solve a circuit. Unless I can write down the KVL equation, how can I? For that reason, coupled coils can be shown just like that, but their dots must be properly put, correctly given, then only I can proceed with a problem, write equations, this, that, and do whatever is necessary. Similarly, last thing is I leave it also another exercise. If you suppose these two coils and these two you connect them in parallel, what will be the equivalent resistance? Suppose this is L 1, this is L 2, and mutual inductance is M, can be also found out. That expression will be slightly different, but the steps should be same. You should be very logical in calculating that. Thank you.